Hello again. This is a video about basic log graphs. Log graphs are going to tie in with graphs that we did on exponentials as well. Because if you remember back to the work that we did in algebra, there is a link between exponentials and logs. And we're going to look at that in a bit more detail. So what does the equation of a log graph look like? Well, I'm going to take this equation. I'm going to say y is equal to log to the base 10 of x. I'm using the base 10 in this case because my calculator works to the base 10, but we could have had something like this: log to the base 3 of x is equal to y. The base can vary. It'll just give us a slightly different shaped graph. So let's go to the calculator and go and put this equation in. So here's my log button, log of x, quite simple. I press execute, and let's go back and have a look at what the table gives us. Now, we seem to have a problem here because the first four values that I've got over there, when x is minus, I'm coming up with errors. Keep going down. When x is 0, I've still got an error. But when x is 1, when x is 2, well, it seems to be the case when x is positive numbers, I'm all right. But something's happening over here when x is a negative number that the calculator doesn't seem to like. Now, if we go and think about the relationship between logs and exponentials, we can take this log form and rewrite it in exponential form. So I can say my base is 10. I'm raising it to the power y. That's going to give me x. So basically what the log is saying is, what power do I raise 10 to? That's the value of y. That's going to give me a value of x. Now, if x is a negative number, as we have over here, I'm asking, what power can I raise 10 to in order to give me a negative number? And that's just not going to work. I just can't get that. So this is the reason why we get errors happening over here. It's a rather unusual feature of an exponential graph, of a log graph, and that is that the log graph doesn't exist when x is a negative number. So this relationship with log graphs and exponential graphs is an important one. So let's go and have a look and see what's happening on the graph of this. We go and get the graphing package up. Here we are. Let's just take it over to the side. There we go. And let's go and find some points that we can plot. Well, we can't plot any of those. We can plot when x is 1. We're going to get that y is 0. We keep going down. When x is 2, y is 0.301. And I'm going to have to scroll out of here, so I've got a bit more space. Let me go up to 4. When x is 3, y is 0.471. And when x is 4, I've got y is equal to 0.6021. which is what we expect over there. So I can see that I'm getting some sort of shape happening in this part of the graph, but I possibly also need to see what's happening down over here. I know that nothing happens on this side of the graph, and the graph doesn't appear to exist when x is equal to 0. So it would appear now that the y-axis is an asymptote for this particular graph. Let's go back to the table. I'm just going to change the set of values that I have over here. I'm going to start now at 0 rather than -4. And I'm going to change my steps. I'm going to change the steps to 0.2 this time. And let's see what we're going to get now on our table of values. So we still have nothing happening when x is equal to 0. There's an error appearing. When x is equal to 0.2, I've got this value of -6.99. Okay, so when x is 0.2, -6.99. So that's happening over there. Let's just scroll in a little bit. 6.99. There we are. Now, when x is equal to 0.4, I'm going to get that y is equal to minus 3.97. When x is equal to minus 6, I'm going to get that y is equal to minus 2.11. And so I've got a bit of a curve appearing here, and that curve should possibly look familiar to you. We know that this down over here, it's going to start approaching the y-axis, but it doesn't appear to cross it. Now, this is what the graph looks like. That's, if I scroll out, we can see that it has a shape that looks like this. And that shape should possibly be familiar to you if we think back to the other graphs that we've done, namely the exponential graph. So if I'm going to put up here the exponential graph y is equal to 10 to the x. And these two graphs look to be symmetrical. In fact, if I go and put in the line y is equal to x running down there, and I reflect this line in this axis, you'll see that it lies directly on top of the log graph. So the log graph is the reflection of the exponential graph. So these two relate to one another. So the exponential graph had an asymptote that was the x-axis, and it rose up very steeply over here. The log graph has the y-axis as an asymptote, and it continues out this way as x gets larger and larger. Just like with the exponential graph, which crossed over here at the point 0, 1, the log graphs are all going to pass through 1, 0 over here, because that's one of the key features of logs. So I'm just going to take a quick copy of this, and let's get back to where we were before, and drop in the copy here. So here we've got our log graphs and our related exponential graph. So this is the graph y equals log to the base 10 of x. This is the graph y equals 10 to the power of x. And they are symmetrical around the line y is equal to x. That's an important feature about exponential graphs and log graphs, that they are the reflection of one another in this line. Y is equal to x. So I hope that helps you with some basic understanding of log graphs. Goodbye.